Okay, let's answer the question here that can be found in your chemistry textbook, chapter 6. The question is, classify each of the following as ionic or molecular and give its name. So let's start with this one, FeCl3. Okay, first question, is it ionic, indicating that it's made up of a metal and nonmetal, or is it molecular, that is a nonmetal plus a nonmetal? In this case, we know that iron is a metal, so this is an ionic compound. Now, the best way to try to name these compounds in general is to come up with the charge above the formula for each of the ions, the cation or the anion. Let's go with the anion. This is chlorine. But as an anion, we know its name is chloride. So here is chloride. It's under group 7A. These are the halogens. And when they pick up an electron to obtain an octet, they end up with a 1 minus charge. So this group all ends up with that 1 minus charge when they ionize. So chlorine is 1 minus. This is iron. Iron is in that area of the periodic table where it can be polycharged. It can have more than one potential charge. So we have to be a little bit careful about this. Now, the way you figure out the charge on iron, which could vary, is to do a net balance of 0 on the total ionic species. That is to say, the cations and the anions must end up with a charge of 0. So for chlorine, we know that 1, chloride, has a charge of 1 minus, and there are 3 of them. So this means that the total charge of the anionic portion of the ion is 3 minus. What is the total ionic charge of the cation? Well, based on simple algebra, we know that this number has to be 3 plus. And since there's only one atom, the charge on this iron is 3 plus. So now we can name this thing. And we're going to name it as iron 3 chloride. So this is iron. The Roman numeral 3 reflects the charge associated with iron, chloride. So since it's an anion, and in the elemental form it's chlorine, but as an anion it's going to end in IDE, or chloride. Okay, let's do this next one. NaSO4. Okay, what is the name of this critter, this formula? SO4. This is a well, first of all, let's just say, is it ionic or molecular? Because it contains a metal and a nonmetal, it's ionic. What is this guy right here, SO4? I don't really recognize it, but it is a polyatomic anion. So we need to go to our table and find it. SO4. There it is. It's a sulfate. It's got a 2 minus charge. So this is sulfate, 2 minus. And sodium, falling under group 1A, when it ionizes by giving up an electron, it ends up with a 1 plus charge. These are all monocharged species. When they ionize, every single element in this group ends up with a 1+ charge when it ionizes, because it gives up one electron and only one electron. So this is 1+. And as you can see, the stoichiometry of the formula, sodium 2 sulfate 1, is understood. That reflects the charges above the two ions. So this 2- ends up down here as a 2, and this 1+ ends up as a 1 here. You could think of it with parens and a 1, but since it is a 1, we don't need to include the parens. So this thing is going to be called sodium sulfate. Sodium sulfate. Okay, let's go with this guy. NO2. Is it ionic or molecular? It has no metals. These are both nonmetals, so it's molecular. And because it's molecular, all the electrons are shared, and there's no need to attach a charge to either one of these. In fact, there is no charge. But instead, we need to identify the stoichiometry. That is to say, the number of atoms in each one of this molecular group. So we use the prefixes mono, di, tri, tetra, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, and deca for 10. Okay, now we have one nitrogen, and because it comes first, we use its elemental name. Now, as a first substituent, we never use mono, even though it is 1. So this is just a plain old nitrogen. But there are 2 oxygens, so this is going to be di for 2, dioxide. So the second component of this molecule is oxygen, and in naming it, it's going to end up with oxide. And because there's 2 of them, it's dioxide. So this is nitrogen dioxide. Okay, let's go with this guy. This is N2. 2 non-metals, so it's a non-metal, so it's molecular. It is diatomic. Diatomic molecules always go by their elemental name, and in this case, it's going to be nitrogen. So this diatomic molecule is called nitrogen, plain and simple. Let's go with this one, PF5. PF5. Metal, non-metal. They're both non-metal, so it's molecular. The first name is phosphorus. It's not mono. We don't need to use mono. It's just phosphorus. And there are 5 fluorides, so this is pentafluoride. Pentafluoride. Okay, let's look at this guy. Carbon, fluoride 4. Carbon, F4. Is there a metal in there? Carbon, fluoride, they're both nonmetal, so this also is molecular. Molecular. Begins with carbon. There's 4 fluorides, so that's tetrafluoride. So this is carbon tetrafluoride. All right, let's do the next grouping of compounds. Once again, classify each of the following as ionic, molecular, and give its name. So let's do this first one, which is Al2, Al2, CO3. There are 3 of these groups. Okay, let's ask the question, is it ionic or molecular? Well, aluminum is a metal, so it's going to be ionic. Aluminum 2 is the cation, and this thing is the anion. What is this thing? We know that it's polyatomic, so let's look at our polyatomic chart and see if we can find it. There it is. It's carbonate, and it's 2 minus. So let's put that charge over carbonate 2 minus. What is the charge on aluminum? So we look at the periodic table. There's aluminum. It's in group 3A, and when it ionizes, it loses 3 electrons, and it ends up with a charge of 3 plus. So that's a 3 plus. And as you can see, these charges cross and give the stoichiometry, or the ratio between the cations and the anions. So there are 2 aluminum cations for every 3 carbonate anions. So this thing is called aluminum carbonate. We don't have to use a Roman numeral because aluminum is monocharged. All of the elements in this group, when they ionize, they form a 3 plus charge, and that's all they form. It's never going to be anything other than 3 plus for these elements. Therefore, we don't need to indicate a Roman numeral, since it's always going to be 3 plus. So this is aluminum carbonate. Let's work with this guy. This is ClF5. Is it ionic, molecular? There are no metals. Chlorine and fluorine are both nonmetals, so this is molecular. Because it's molecular, there are no charges involved. The electrons are shared, but we do need to indicate the stoichiometry of the formula. That is to say, the chlorine, which has come first, is named as chlorine. It's elemental name. But the second atom is named as a fluoride, and there are 5 of them, so that's pentafluoride. Chlorine pentafluoride. Okay, let's do this guy. So this is H2. It's a diatomic molecule. There are no metals, so it's molecular. But like all diatomic molecules, like H2, they're given their elemental name, and that's it. So this thing is called hydrogen. Hydrogen. Okay, let's do this one, Mg3N2. Okay, let's figure out the charges. Nitrogen, what's the charge on nitrogen? Nitrogen is under group 5A. When it ionizes and picks up 3 electrons, it ends up with a 3 minus charge. But first of all, let's ask the question, is it ionic or molecular? Magnesium is a metal, so it's ionic. What is the charge on magnesium? Go to our periodic table. There's magnesium. It's going to lose its 2 valence electrons and end up with a 2 plus charge. Also, it is not one of these poly-charged metals. It's in column 2A, and so it ends up with a 2 plus charge. It'll always be 2 plus and never be anything else when it ionizes, so we don't need to indicate a Roman numeral when we're naming this. As you can see, the charges cross to give the stoichiometry of magnesium 3, nitrogen 2. So this is going to be called magnesium nitride. The second, the anion always is going to end in "ide" if it's a single atom. Okay, let's do this one, ClO2. ClO2. Is it ionic or molecular? There are no metals. These are both non-metals, so it's molecular. Don't need to worry about charges. There are no charges. The electrons are shared. So this is chlorine. It comes first, so it ends up with its elemental name. Chlorine. This is the oxide. The second one is named with an "ide" on the end, so this is oxide. There are 2 of them, so it's dioxide. So this is called chlorine dioxide. What about this one? This is CrPO4. CrPO4. Okay. Let's charge these things. So let's chromium. Chromium is right here, and it is a polycharged metal. So at this point, we're not quite sure what it is. We can figure it out from the anion. Let's look at our polyatomic. It's a polyatomic, PO4 polyatomic. Let's look for it. It's phosphate. It has a 3 minus. So its charge is 3 minus that we've memorized. We know that the charge balance has to be 0. There's one of these and only one, so it gets a charge of 3 minus. Don't let that 4 fool you. It's part of the anion, so we could put parens and a 1s there if we wanted to, but it's not necessary. So the charge of this anion phosphate is 3 minus. So this has to be balanced with a 3 plus in order for it to add up to 0. There's only one chromium, so the total charge on the chromium metal is 3 plus. So that 3 plus is going to be very important because the name now is chromium 3. This is phosphate. Okay. So let's do this next grouping, in which write the formula for each of the following names. So these are a little bit easier to figure out, I would say, because the Roman numerals are given. So let's go with this first one. And what I do is write the symbols. So for tin, the symbol is SN. Okay, and this is carbonate. What's the symbol for carbonate? So we look up here and we find carbonate, and it's CO3 2 minus. So 2 minus, and tin is also 2, so it's 2 plus, and when we cross, it's 2 and 2, so we simplify it. So this, the formula is SN or tin, CO3 or carbonate, tin carbonate. Let's do this guy. Lithium phosphide. Let's write the elements. Here is lithium, and phosphide is just this. So don't get confused with phosphate. This is phosphide. It's just a single P for phosphorus. Let's write down the charges. So lithium, based on the periodic table, is under column 1A when it ionizes and gives up an electron and ends up with a charge of 1 plus. So this is 1 plus. Let's look at phosphorus from the periodic table. Phosphorus, when it ionizes, it picks up 3 electrons and ends up with a charge of 3 minus. So this is going to be 3 minus. So we're going to cross these. So the lithium gets a 3 and the phosphorus gets a 1. Let's validate this by doing our charge balance. See if our charge balance works out. 3 minus times 1 phosphorus is 3 minus, a total charge of 3 minus. Lithium is 1 plus times 3, that's a total charge of 3 plus. 3 plus plus 3 minus equals 0, so that's a charge balance, so this works out just fine. Let's do silicon trioxide. I will write the name down. Silicon tetra. It's a tetrachloride. Oh, first of all, I want to say that this is ionic. The tin carbonate is ionic because it has a metal, and the lithium phosphide is ionic because it also has a metal. But silicon trichloride is molecular because there's no metal. Okay, so silicon is Si, And it's just one of them. The chloride is Cl, and there are 4 of them. So this is silicon trichloride. Okay, let's do the next one, which is magnesium 3 oxide. Magnesium 3 oxide. All right, its name, Actually, it's manganese. Manganese 3 oxide. Manganese 3 oxide. So you write down the symbols, which are Mn and oxide. Is this a metal or non-metal? Manganese is a metal, so it's ionic. Okay, the charges are 3 plus, and oxide, we know that it's 3 plus because it tells us right there, Roman numeral 3 gives us a 3 plus. That makes labeling this charge very easy. Oxide is always going to be 2 minus. It's under group 6A. It's going to take on 2 electrons. That's going to give it a 2 minus charge. So this is a 2 minus charge. So now we're going to cross these. Manganese gets a 2, oxide gets a 3. Let's see if that gives us a charge balance of 0. 3 times 2 minus is 6 minus, plus 2 times 3 plus is 6 plus. So 6 plus plus 6 minus equals 0, charge balance. So this cross method that we use is validated by the fact that we end up with a charge balance of 0. The next one is bromine. 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 So, is this ionic or molecular? No metal, so it's molecular. So we know that bromine is the elemental name, but we know as a molecule, bromine is a diatomic molecule, so this is Br2. Br2. Okay. Let's go with the next one, calcium bromide. Calcium bromide. Calcium bromide. So again, when you get these names, you write down the symbols. And then you write the charges above. Bromide, that's a halogen. It's 7A. When it ionizes and picks up an electron, it's going to end up with a charge of 1 minus. So this is 1 minus. What about calcium? Calcium is a metal under group 2A. It's not polycharged, it's singly charged. It's going to end up with a 2 plus when it gives up its 2 electrons. So this is 2 plus. We're going to cross them, so the calcium gets a 1, the bromide gets a 2. Let's do our charge balance thing. 2 times 1 minus is 2 minus, plus 1 times 2 plus is 2 plus. 2 plus plus 2 minus equals 0, so that works. Okay, so let's do this last group. I'm going to write the names down. Sodium carbonate, Sodium carbonate. Okay, so just write the symbols. Sodium is sodium. Carbonate is CO3 2 minus. I know that because I've memorized them, and in our polyatomic anion table we find a carbonate, which is CO3 2 minus. So this is CO3 2 minus. We know from our periodic table that sodium in this column, 1A group, when it loses an electron, it becomes 1 plus. So sodium's charge is 1 plus. Again, we cross these. So sodium gets a 2, carbonate gets a 1. We don't need to use parens. Let's see if that charge balance works. Don't get this confused. This is kind of like a bracket and a 1 that we don't normally use, but for this I will put in a bracket and 1 so you don't confuse that with the 3. So this is 2 minus times 1, which is 2 minus. And then the charge for the cation is going to be 2 sodiums times 1 plus. That's going to be 2 plus. 2 plus plus 2 minus equals 0, so the charge balance works out, so that's the formula. Okay, let's go with nitrogen dioxide. Nitrogen dioxide. Nitrogen dioxide. Is this metal or non-metal? Oh, by the way, this is ionic. Ionic, because there's a metal. How about this? Is there a metal? No, nitrogen is a non-metal, and dioxide is, oxide is also a non-metal, so this is molecular. A molecular compound. Write in the symbols. It's molecular, don't need to worry about the charges. Nitrogen, there's 1. Oxygen, oxide is 2. So that's nitrogen dioxide. These ones are pretty easy. Okay, the next one we have on our list is aluminum. I'll write it out. Aluminum nitrate. So we just write out the symbols. Aluminum is Al. Nitrate, what is that? That's a polyatomic anion. We look on our sheet and try to find it. There it is, nitrate, NO3, 1 minus. NO3, 1 minus. What's the charge on aluminum? There it is. It's a monocharged species. It's going to give up 3 electrons and end up with a charge of 3 plus. So this is 3 plus. We then cross these. Aluminum gets a 1. Nitrate, we have to put in parens, gets a 3. So this is aluminum nitrate. Okay. Next one is copper 1 nitride. Now, don't get confused. Nitride, that's not nitrate or nitrite or anything like that. That is nitrogen. Nitrite is nitrogen. So write the symbols. Copper, nitrogen. Copper, because of that 1, is a 1 plus. We look at the periodic table for nitrogen. Nitrogen is right there. It's 5A. It's going to pick up 3 electrons, and its charge is going to be 3 minus. 3 minus. Oops. Three minus. Okay, so we're going to cross these. Copper gets the 3, nitrogen gets the 1. Let's do the charge balance. See if that works. This is 3 negatives, so that's 3 negatives plus 3 times 1 positives. That's 3 positives. So that's 3 plus 3 minus equals 0. So this is the correct stoichiometry. Copper 3, nitrogen 1, copper 1, nitride. Okay. Let's do the next one on our list. Potassium phosphate. Potassium phosphate. Okay, potassium is that. Phosphate is PO4. How do I know that? Because it says so on here. Phosphate is PO4. It has a charge of 3 minus. 3 minus. Potassium is a charge of 1 plus. How do I know that? I look up my periodic table. Potassium, column 1A. Potassium, column 1A. Is a charge. It's going to give up an electron. It's going to end up with a charge of 1 plus. Okay, we're going to cross these. The potassium gets a 3. The phosphate, I'm going to put in these imaginary parens and a 1, just so you don't get confused with that 4. That 4 is part of the phosphate anion, 4 oxygens. So let's validate this with our charge balance of 0. 3 minus times 1 is 3 minus plus 1 plus times 3 is 3 plus. 3 plus plus 3 minus equals 0. So this is a stoichiometry. Potassium phosphate. There you go. Okay, last but not least is cobalt 3 sulfate. Let me write that down. Cobalt 3 sulfate. So that's going to be CO for cobalt, SO4 for sulfate. How do I know that? I look at my table of polyatomics. There's sulfate, SO4, 2 minus. So I've memorized this. This is a 2 minus. Cobalt's 3. That gets a 3 plus. So these are going to cross. So I need to put a parens around the sulfate. It gets the 3, and the cobalt gets the 2. Now, does that charge balance out to a 0? Let's see. 3 times 2 minus is 6 minus. Plus 2 times 3 plus is 6 plus. So 6 plus 6 minus equals 0. So that's a charge balance. So this is the formula for cobalt 3 sulfate.